All right, welcome to geometry. Today we're doing lesson 3-5, prove triangle properties. This is our second day of doing proof lessons. Today's date is Tuesday, January 12th, 2021. I got good news. I get the vaccine tomorrow. It's pretty awesome. Who wants to read the objective? Wyatt was first.
Create proofs and understand common errors with proofs in general and specific cases.
There it is. All right, so that's kind of a mouthful. I might explain that at the very end, but generally speaking, the homework, they'll either ask you to find errors in student proofs, or they'll make you help a student finish their proof. Hello, Mr. Warner. Ooh, things for me. Thank you. That's weird. A blank page. Oh, the printer is like malfunctioning. What is going on? You guys want to see the notes I printed out? Aren't they beautiful?
Those are beautiful.
Yeah, maybe I can go like this and you can see them even better. Yeah, look at those notes. They're pretty excellent notes, if I do say so myself. Don't know. And again, I upgraded to Big Sur, the new operating system for Mac OS X, and I have a feeling that has ruined everything. Maybe I should share my screen again. That would be a good idea. All right, so let's do a proof. I want to prove that the sum of the interior angles of a triangle sum to 180 degrees. And you might be thinking, maybe you're thinking one of two things. What does that mean? Or maybe you're thinking, haven't we already done that? Don't we know that these angles, angle A, angle B, and angle C, those add up to 180. You've told us time and again that that's a theorem. Yes, it is a theorem, but we have never proved that theorem. And in order to actually use theorems mathematically, you have to have them proved. So I'm maybe a bad teacher. I've been letting you use an unproven theorem. So let's go ahead and prove it today. And forever and ever, you're allowed to use the fact that the interior angles of a triangle always sum to 180 degrees. So I've already done the first few steps of this proof, but you could start with any old triangle. I started with a very specific triangle that has a 90-degree angle here. And the first thing that I did was I constructed, what you know how to do, you can construct a parallel line to line BC, and that is line DE. So far, so good. We all are okay. If I had a ruler and compass, I could construct this parallel line. And I just happen to know that that angle is 50 and that angle is 40. Maybe I was told by some divine something that I have those angles. Maybe the textbook told me, I don't know, but I have those angles. Let's continue this proof. So again, my final line is going to be that this angle, this angle, this angle add to 180 degrees. Typically with proofs, you can write the last line as your first step, which is kind of interesting, right? Because it's not about what, we know the what. The what is right here. We want to know the why. Why is that true? So here's the what, and I hope I have enough room. I'm going to write kind of small. I will say, therefore, the measure of angle, I'm going to be kind of, I'm going to call this angle 1 and angle 2 to make this as simple as possible. I don't want to say measure of angle ABC, because there's only like, if I'm talking about 1, you know it's clearly that angle. So I'm going to say measure of angle 1 plus measure of angle 2 plus measure of, I do have to be specific about this one. If I say measure of angle A, what am I talking about? I have to say BAC in this case. Say measure of angle BAC, measure, oh, come on now, measure of angle BAC, yes.
I didn't understand the part when you said, like, how come we're not, like, why you didn't start with A being 1, B being 2, and C being 3. Because you did B1, C2 instead of A1, B2, C3.
I'm assigning those variables. My variable is a 1. It's very informal. I just want to say, if I say the number 1, I want you to think, oh, he's talking about this angle right here. If I say 2, I want you to think this angle right here. My pen and computer is all laggy today. I don't know what's going on. Big Sur upgrade. And then if I'm talking about that angle, I will specifically say the measure of angle BAD. 1 and 2 are just a shorthand way of identifying those angles.
Okay, good.
Yeah, nice question. Okay, so we have our conclusion. We don't know the reason for our final conclusion. Let's go ahead and do the givens. What is a given up here. And some things I've given to you already. So what are they? Kira.
I think maybe it's given that line BC is parallel to DE.
Yeah, BC is parallel to DE, line segment DE. I agree. And I did that by construction, or maybe you can say, well, the picture said it. So either way, yeah, it's given to us. Yeah, what else? Is there anything else that's given to us, or do we need to start proving this? Yeah, what?
Well, it is given to us that angle BAC is equal to 90 degrees.
Okay, yeah. So you can come down here and say measure of angle, and that's kind of an important one, all right? Because I eventually am going to have to talk about measure BAC. So measure of angle BAC is equal to 90 degrees. And again, that is just given to us. Nice. All right, anything else? Asha?
Well, isn't it like angle DAB is also given 50 degrees?
It is, yeah. That's more information that's given to us. Let's write it. And one cool thing about proofs is, yes, you can be concise, and maybe we don't need this, and maybe we will use it, but go ahead and state it. You can always cross it off later if you don't need it. So just state every single thing that you might need. It'll avoid you from making mistakes. So measure of angle DAB is given to be 50 degrees. Also given. What's the last given that we can see? Yeah, Charles.
Angle CAE is equal to 40 degrees.
Yep. CAE is equal to 40 degrees given. And the lag here is making it really hard to write. Cool. Okay, we have our givens, we have our conclusion. Time to do the hardest part, the why. How do you connect this to the fact that there should be 180 degrees for the interior angles? I'll give you guys some time to think, but it's stuff that we've already talked about before. There's nothing super brand new here. Every single theorem that we've ever used is, not every single one, but some of them that we've used in a few lessons ago, we're gonna use right now.
Wait, what was your question? I didn't really get that.
What do we do next?
Oh.
Like I'm giving the hint that we're probably going to use a theorem that we've been using before, and maybe I can open those up again, but there are theorems that deal with corresponding angles or vertical angles and stuff like that. You have to be thinking of all the different tricks that we've learned so far to try to prove that things add up to 180 degrees or angles are the same. What?
I think we can use the theorem of alternate interior angles to find the measurement of angle ABC and the measurement of angle ACB.
Yeah, and we can just call those angle 1 and 2 if you want.
Oh yeah, 1 and 2.
I try to make it a little bit easier. Yeah, so let's go ahead and try to find this one. Let's go ahead and say, I know the measure of angle B. Measure of angle 1, in this case, is equal to what, Wyatt? Oh, are you there? He turned off his camera. He might have left. Well, let me write down what he said, and then someone else can fill in. This is exactly like the homework question. Maybe the homework question would be better written. Wyatt gave part of the answer, but you need to fill in the rest of them because he left on Zoom. His reason was alternate interior angles are congruent, and my writing is taking too long because of lag, so I'm going to type alternate interior angles are congruent. What is the measure of angle 1? Charles?
Would it be 50 degrees?
50 degrees again, yeah. So the inside armpits of the Z, as long as you have parallel lines, which we do, we stated that right here as one of our givens, the armpits are equal to each other. So angle 1 must be equal to 50 degrees. So we come down here, and this is 50 degrees. And we can do kind of the same thing on the right-hand side. Can anyone give me the statement and the reason to talk about this angle and what measure it should be? Jade?
So angle 2 is equal to 40 degrees. And the reason is all imperial angles are congruent.
Perfect. Yep. And we're basically done, because check it out. If I actually label the diagram with all the information that we have in our actual proof to make our diagram match, this now is 50 degrees. This now is 40 degrees. And if you want to do some mental math, 50 plus 40 is 90. 90 plus 90, 180. We are there. Those add up to 180 degrees. Now, you have to be a little bit careful about your reasoning. You really just need to say, add them up, property of addition. Add / substitute, depending on what you're talking about. In this case, it's just purely add. So I'm just gonna say add angles. You're done. You've proven it. Remember, you're gonna end with a little black box in the bottom right corner, QED, whatever you want to do. Oh God, my lag. I'm not trying to do that. Okay, I'm just going to write QED. QED, quorum et determinum. We have proven what we set out to do. And we're done. All right, so there is a proof. There are many types of proofs, but this is kind of a good question to ask at the very end of the proof. Does this proof that we just did, so pat on the back, guys, good job. Does that prove that all triangles have interior angles that sum up to 180, or just that triangle? And everyone is going to vote on this. You're going to say, we're going to do thumbs up. Yep, we proved all triangles. You're going to do thumbs down. Nope, not all triangles, just that triangle. Everyone vote. Camera's on, or maybe you can use the chat and say all triangles are just this triangle. Is it just this triangle? Is it all triangles? What are we proving here? Ah, Emma did the no. That works too. And the no's have it. The thumbs down have it. But who wants to volunteer and talk about why? Why is it only this? Charles?
Well, we only did this proof for one triangle. We didn't change it in any way. It's just this one triangle. I don't know.
Okay, well, let me ask the question a different way. So how could we have changed the picture up here, or the original type of question, to make it so that we did a proof for all triangles? What tweak could we do? Charles?
You could probably change the starting angle to something different.
Like what?
Like instead of 90 degrees, it could be, I don't know, 23 degrees.
Okay, yeah, just so a different angle. So I'll call him Wyatt in a sec, but the problem with doing that is, in order to prove for all triangles, you'd have to go 90 degrees, 23 degrees, 17 degrees. And then you're like, wait, I went 16 to 17 when I have to do 16.5. Wait, if I went between 16 and 16.5, when I have to do 16.25, when I have to do 16.00001 and 16.00001, I'd have to do an infinite number of proofs, which seems kind of tedious. So you're right, that is an approach, but it's not an efficient approach. But there is a trick. All I have to do is switch like 3 numbers essentially to something else, and then it proves for all cases. And it's a super powerful proof, which we'll do in the second proof. Any ideas? What?
Maybe you have to use an equilateral triangle where all angles are the same.
But then, so you're right, that would be a different case, and I would prove it for all equilateral triangles. The problem is, I want to prove this for all any triangles. Because your theorem states any triangle has interior angles that add up to 180, not just for equilateral triangles, right? So here's the trick. What if instead of saying 50, 90, and 40, what if I just didn't have those at all? What if I instead had nothing and instead of putting 50, I put, I'm gonna put an X, I'm gonna put a Y, and I'm gonna put a Z. But Mr. Sindel, that doesn't work because that doesn't add up to 180. Yes, it does. Check this out. X plus Y plus Z is a line. A line angle is 180 degrees. By doing substitution, this angle is now an X. This angle is now a Z. And because we knew originally X, Y, and Z were on a line and added up to 180 degrees, X, Y, and Z also add up to 180 degrees for every case. That is the Charles Peak solution of an infinite number of triangles, but we use variables instead of letters. And that's the general theme that I want you to take away from at least this first question is, okay, that's how to do a proof. But if I have variables instead of letters, that proves it for all triangles. If I just have numbers, yeah, it works for that one triangle. All right, let's try another proof. I'll write down a note, just this one. Let me type out a more specific answer just in case people are confused. So just this triangle because there are specific angles. And then in the second case, check this out. I don't have any angles. So example 2, I'm going to go ahead and do the conclusion right now. I have angle 4, 1, and 2. They could be any angles. Yes, I could say it's not drawn a scale and I could drag this around on GeoGebra, but right away, I'm going to go ahead and answer the same question. This proves it for all triangles. Why? Because the angles were generalized as variables, not specific angles. That's the difference that I want you to take away. Okay, so let's do another proof. So what is this one asking? Prove that if I add up angle 2 and angle 3, these two angles, they actually equal angle 4. This is a theorem that I don't think I've shown you yet, but it is true. And it's true for all triangles. And we have to assume some really cool things when you get to the college level, that we're in the second dimension, that we're on a plane that's flat, not like on a donut or anything like that. But yes, this always works. And it's kind of a cool theorem, right? I don't know if anyone's mind is maybe not blown, but like, really? That always works? It does always work. And we're going to prove it right now. Angle 2 plus angle 3 always add up to angle 4. And the name of this theorem, this is not the name I learned, but the Khan Academy calls this exterior triangle angle measures equal the sum of measures of two interior angles not adjacent to it. Ugh, what a mouthful. All it means is 2 plus 3 equals 4 in terms of this diagram. Don't use this one. Don't use the one that's adjacent to it. That's why I said not adjacent to it. Okay, so how do we do this? Let's start out by doing the final answer. So, screenshot. Measure of angle 2 plus measure of angle 3 is equal to measure of angle 4. That is our final answer. We know that. Again, geometry is not about the what. That is the what right there. It already gave us the what. We want to know the why. And we don't know the reason yet. Ooh, let me do the little therefore symbol there. This 3 little dot. Therefore, blah. All right. What is given to us? By the way, guys, since we've proven the fact that there are 180 degrees in a triangle, we can use that. It's not given to us right now, but it is a theorem that we will eventually invoke in this proof. It doesn't look like anything else has been given to us. Oh, maybe you see something. I don't know. Kira, what'd you see?
Never mind. I thought I did, but never mind.
Okay. Yeah, Charles, what do you see?
Angle 4 plus angle 1 is equal to 180 degrees.
That is the perfect first step. Yes. While it isn't something that's given to us, it is the first step. So you're getting ahead of me. I'm going to catch up to you. But there's not really a whole bunch that's given to us in this problem aside from that's angle 4, that's angle 1. Let's go ahead and use the fact that 180 degrees is a line. Supplementary angles or linear pairs form supplementary angles, I think is the full theorem name. Let's go ahead and write down what Charles said. He said, if I add up the measure of angle 4 plus the measure of angle 1, just add these two together, they'd add up to 180 degrees, equals 180 degrees. The full way that you state that for your reason is these are called a linear pair. Linear pair. Again, linear meaning they're on a line, pair meaning there are two of them. If you have two angles that are on a line, linear pair. Do I want to say
Or
angles that are
supplementary.
linear? I'll just say linear pair or supplementary. Yeah. Let's simplify as much as possible. Supplementary. Done. Cool. All right. I told you guys one of the theorems that you're going to use. It's the last theorem that you just proved. How do we say that? You actually write out the statement with the reason. I'm not going to give it to Charles. He just did the last one. Sorry, Charles. It's going to be someone else. Again, what did we just prove on the front side of this piece of paper? What did we just prove over there? I'm going to use that now to prove this one. And that's kind of how mathematics works. Prove something, do a harder proof. Use that to prove something harder. Use that to prove something harder. You can go on and on. Maybe forever. I don't know. Is math endless? It's a good philosophical question. Come on, guys. Someone tell me. I'm basically going to copy this. Prove. Here's the reason. Ready? Actually, I'm going to simplify that even more. Let me type that over here. Here's your reason, but you guys need to give me a statement. The sum of interior. Wait, it is copying that word for. Oh, let me do this. Sorry. Why is my mouse not working? Ah, there. Cool. There's a reason. Interior angles of a triangle sum to 180 degrees. What is the statement that I have? Let's zoom in back here. What three things add to 180 degrees? Esha.
Angle 1, angle 2, and angle 3.
Yep. 1 plus measure of angle 2 plus measure of angle 3 equals 180 degrees. And by the way, you might have asked the question, why is Mr. Sandell writing M in front of the angle? Because M stands for the measure. If I just did angle 4 is just an angle. If I say the measure of the angle, then I'm talking about the number of degrees. So I have to put M, otherwise it's not a number. If I just do the angle, it's not a number. Okay, so the measure of those add up to 180 degrees. I'm really close to being able to solve this already. There's like one more step. Question from Kira?
Yeah. Like, are we supposed to, in Khan Academy, is it going to ask us, like, is this side angle or whatever, angle side? Okay.
Yeah, it'll ask stuff like that. It also requires you to remember what an altitude is. Hopefully you remember from our construction unit. Oh, altitude, that's a 90-degree angle because it has to be the height of the triangle. Altitude means height, right? Yeah, what do you got?
Okay, so what I'm thinking about is that the measure of angle 1 has been used both times in the equations. Therefore, the leftover in both is the measure of angle 4 and the measure of angle 2 plus measure of angle 3. Therefore, the measure of angle 4 must be equivalent to the measure of angle 2 plus measure of angle 3.
Yep, and then the way that because proofs are even easier than what you're saying, that is all the hard reasoning that I will write down to make sure everyone can follow. But let me go ahead and we're done. All you have to do down here is write down what Wyatt said in the simplest possible terms. The simplest way of saying that is substitution and subtraction. You're done. That's all Wyatt did. He did substitution and subtraction. This is a finished proof. Let me explain why this proof makes sense. What did Wyatt really say? He said this. If I have 180 degrees, and this is 180 degrees, I can say that this is equal to this. Okay, I'll even write out, this is not, I'm going to do it in a different color. You don't have to write this in your proof because this is enough. You can say measure of angle 1 plus measure of angle 2 plus measure of angle 3 is equal to measure of angle 4 plus measure of angle 1. Why are we allowed to say that? Because they're both 180 degrees. This side must be equal to that side. Give me a head nod one way or the other. No, confused. Oh yeah, that makes sense. No, confused. Okay, so if I said that I had x is equal to 3 and y is equal to 3, would you agree that x is equal to y? Okay, so this is x, this is y. I just rewrote them. They're bigger. And I say they're both equal to the same number. Therefore, those two expressions must also be equal to each other. In the simplest form, it just means I'm substituting. Yeah, Kira.
What's angle 4?
Angle 4 is just, in terms of the diagram, it's that angle right there. But just think of it as it's some angle. Maybe it's 23. Maybe it's 19. Maybe it's 123. It's some angle.
Why does it matter? Why is angle 4 important? Because not even a part of the triangle.
Because what we're trying to prove is that what is measure of angle 4? That's the quest that we're on right now. What is 4? And it's saying, the quest says, if you just add up these two angles here and here, it actually does equal 4.
I see.
Yeah, that's a good question. Okay, and then here is the final step. Remember, what we just did right now is called substitution. And what I told you guys, Wyatt did substitution and he did subtraction. Let me do the subtraction for you guys right now. Subtracting, well, Wyatt said, hey, there's a measure of angle 1 on both sides. Subtract measure of angle 1 from both sides. So minus measure of angle 1 minus measure of angle 1. And what's left over? Well, just cross them off. And look, you have exactly this line right here. Measure of angle 2 plus measure of angle 3 equals measure of angle 4. We're done. So I'll go ahead and leave the intermediate stuff, but as a general idea, proofs, make them as easy as possible, especially for me. Whenever I see a complicated proof, I'm like, there's got to be a better way of doing this, and there typically is. There's your proof. That's all I've got for you guys today. And again, 90% of your homework is going to be based off of these two proofs. If you really understand them right now, you're going to fly through the homework. If you don't, hopefully the homework will let you experience like, oh yeah, that's why this makes sense or why this makes sense. There are a few problems that talk about proofs other than these two, which are good to just get you understanding how proofs work. But again, I just want you to kind of focus on how do you prove something? What are some general mistakes that people make when they're doing proofs? Any questions before I leave you guys for the last 5 minutes to try to do some homework? Yeah, Wyatt?
What are we doing in Algebra 2 today?
We're starting on our new unit, logarithms, which is, again, most teachers dread teaching it. Most students dread learning it, but I think it's really easy. I'll simplify as much as I can for you guys. No more questions? I'll stop the recording.